Introducing the Critterbot, a project by the Reinforcement Learning and Artificial Intelligence Group, or RLAI, at the University of Alberta. The Critterbot is a new robotic platform for doing research in reinforcement learning. We hope to gain experience in connecting a low-level array of sensory inputs to high-level knowledge, in teaching and interacting with a lifelike artificial agent, and in both lifelong and real-time reinforcement learning. The Critterbot is equipped with a diverse range of sensors. Some of these help it to sense the outside world. These range from infrared distance sensors, infrared and visible light sensors, magnetic field sensors, and a microphone. Other sensors help it to know about itself. The Critterbot has an accelerometer, a gyroscope, and sensors for motor temperature, motor velocity, motor current, and system voltage. It also has 16 LEDs and a speaker that give the Critterbot a way to give feedback to the outside world, as well as a tail that enables it to interact with its environment. On the front of the Critterbot, you see two brass connectors that allow the Critterbot to connect with its docking station. Here, the Critterbot can recharge its batteries so that it can continue learning. The Critterbot is driven by 3 custom wheels. These give the robot the ability to travel in any direction regardless of its current orientation. So unlike a car, which can just travel backwards and forwards, the Critterbot can also move laterally, as well as rotate on the spot. Using this joystick, I can control the robot, but you can imagine an artificial agent might be able to control the robot as well. One of the goals of the Critterbot project is to investigate lifelong learning. This requires the Critterbot to be aware of the remaining charge of its batteries, and then it be able to charge itself autonomously. To facilitate lifelong learning, the Critterbot has been given a docking station, which it can use to charge its batteries. The task of quickly and successfully docking the Critterbot is an ideal candidate for machine learning based on interactive experience. One reinforcement learning task that can be explored on the Critterbot platform is proximity avoidance. If you look at the top of the Critterbot, right now it has all blue LEDs, and this means that it's receiving a positive reward. When an obstacle enters its proximity, some of the LEDs will turn red. Using the principles of reinforcement learning, the robot will learn, by trial and error, a sequence of actions or a policy that lets it return to a rewarding state like it's in right now. The lights here are red, so the robot is receiving negative reward, and eventually it should learn that it should be changing its behavior to get out of this state and return to a rewarding state. So this is interesting. The Critterbot has learned to rotate itself before it moves itself away from my foot. So the policy here is to rotate and then move away when it senses my foot on its left side. And you can see that when it does this, the robot is successful in returning to a rewarding state. Using the same principles that the robot used to learn the behavior you just saw, we can have a human apply reward to the robot and thereby teach the robot tasks that the human wants to see. Right now the robot is still and it's still receiving positive reward, but using this Wiimote, I can communicate to the robot that I don't like its behavior with negative reward, and its behavior will change so that it maximizes reward. When I see a behavior I like, I can apply positive reward, and the robot will start behaving in that way. So I've just told the robot that I like it to spin. And I can tell it I don't like spinning anymore, and I prefer that it did something else. Stand still again. Using the Wiimote, we can also train the Critterbot to return passes. If you want more information on the Critterbot, you can visit the Critterbot website at critterbot.earlcommunity.org. You'll also find a link to a Critterbot simulator there. Thanks for watching.